Hey everybody, Harold here. Today I want to start a new series. As a freelance data analyst, I have to work in several different languages. The three most common I work in are SQL, Python, and R. Do a lot of pandas in Python and tidyverse work in R along with SQL. I want to compare a lot of different functions in those three languages to show you the similarities and differences and pros and cons of using each. So I want to start with the series on window functions. Today's is part one, ranking. Uh, but first, I want to give you a general overview of how and why and when you would use these. Of course, a lot of that is based on maybe your job or personal preference or to what you know. But for feature, for ease of use, tidyverse, if you know R, this stuff's easy to use. Uh, Pandas is more straightforward, but you have to know Python kind of, so that might be a constraint. And SQL is really easy, of course, if you're in a SQL environment, and it's got a really familiar syntax and easy to pick up for a lot of people. Performance. If you have a large data set, R slower. Pandas, okay, efficient with large data sets. SQL can handle about anything. Flexibility. Uh, Tidyverse highly flexible. Python, pandas, flexible, various methods. SQL is less flexible for non-SQL tasks. So if you're working in a SQL environment, use SQL. If you're trying to go back and forth to these other two, it's less flexible. Dependencies, tidyverse requires dplyr package, tidyverse. Uh, that's no big deal. It's just an install packages and library command. Same with pandas. Install pandas, import pandas. SQL, you don't need to have any packages in SQL. Best use case, medium data sets in R, simple workflows, data manipulation in Python, and SQL large operations, large environments, large data sets. Throughout this series, I'm going to maintain a cheat sheet and update it as we go. I've got the ranking functions on here already. You can take a glance at this real quick. These are the ones I'm going to compare. If it says NA, it's not available in that language. So we have row number, rank, dense rank, entile, and SQL in their equivalents in pandas and the tidyverse. So let's start in SQL. I'm running SQL Server 2019, I think this one is. I need to upgrade. Uh, I've got a file here called TBO Acme Cleaning. I will post the table script for that on my in my GitHub repository. For now, you can follow along and pause and type if you wish. So I just selected star from DBO Acme Cleaning. Here it is. It's employee database. Just some fake data I made up. acmewidgets.com. So row number, the first ranking function. Assigns a number sequentially, ignoring any ties arbitrarily. Whatever it sees first, it takes first. It's good for creating ID columns and identifying duplicates. So I selected full name, department, salary. And here is the row number window function. In SQL, all window functions require an over clause. Not all of them require an argument. They all require an over clause with at least an order by. So I want to make a new column called row number. Well, using the function row number, no argument, over, in parentheses, I want to order by salary, descending, and I want to call that, alias that column row number. So it's just going to give me 1, 2, 3, 4, 5, ignoring ties. It should. So let's run that. So same as the index 1, 2, 3, 4, 5 through 14. Even though Barbara and John are tied, Thomas, James, and Mary are tied. It's just going whichever one it sees first. It's assigning sequentially. Rank again, rank sequentially, but it uses a skip method for ties. And when I say skip, skip would be one. Let's say 1, 2, 2, 4. Dense is the other argument. It would be 1, 2, 3, 3, 4. So when there's a tie, skip skips the number. When there's a tie, dense calls it the same number and moves on to the next one. So same select, but now have rank, no argument over order by salary descending as sal rank. So we'll run that one. And I have 1, 2, and when there's a tie, it's 3, 3. It skips 4, goes to 5, 6, 6, skips 7, 3, 8, so it skips 9 and 10, etc. Rank. Dense rank uses the dense method up here where I said 1, 2, 3, 3, 4. Let's run that one. We have 1, 2, 3, 3, 4, 5, 5, 6, 6, 6. So it doesn't skip any. It just gives them all the same rank when they're a tie. Intile, the last one here, breaks your data into percentile groups as evenly as possible. If you did n equals 4, it would give you quartiles. So let's try that one. Intile, and you do put an argument in here, 4. You got to give it an argument to split it up. Over, again, order by salary descending as sal quartile. So let's run that one. So we have 1, 2, 3, 4, 5 in quartile 1, 5 in quartile 2, 5 in quartile 3. So it's split it evenly. If we did, say, an odd number, so we'll change intile to intile 5 and rerun it. So I have 1, 2, 3, 4. That's not going to work because it's even. We have to use a number not divisible by. The 20 is not divisible by. So we'll 7. And we'll see how that comes out. So we have 3, 3, 3, and 3 till it gets to there's 2 left over and there's only 2 in the 7. So as evenly as possible. And let's just one last time run them all together now. One statement. So you can see how they compare. So we get down here, we have 10, 8, 6, second quartile. So it starts to get uneven down here. 20, 18, 9, and fourth quartile for Sarah Moore. One more thing, you can add a partition by if you want to group these. So you want to rank salaried by department. I chose dense rank, but no argument over partition by department. So that's the grouping. Then order by salary. So when it gets to the next department, it should change and start re-ranking. So let's run that one. And so HR only has 1. Dense rank, they're tied, and IT, they're tied at 2. And then it resets for management, 1, 2, 3, 3, and then resets for marketing. So it's partitioned by department, ordered by salary, and then ranked dense. All right, let's move on to Python. I am using a Google Colab. If anybody hasn't used Google Colab, it's great. The great thing about it is you just have to put Google Colab in. It's free to sign up for. I'll put my notebook in my GitHub repository. You run Jupyter notebooks in here. And the greatest thing about it is I won't use it, but you can use a GPU if it's available. I guess even a TPU now. And if it's available for free, or you can buy time if you're into it. So if you do any large data sets or maybe deep learning or machine learning, you really want to look into this. What it does for us, though, is it allows us to run a Python script in a notebook online without using any of our own compute resources. So ranking Python pandas, parameters method, it's a little different than the SQL. You put rank and then you tell it the method, except for entile. We'll get to that. So we have average, assigns average, min, max, assigns max. We'll see what these mean in a second. First assigns in rank in order of their appearance. Dense is like min, but the ranks are consecutive. Ascending sorts in true or descending false order. And in a handles not a number of values, you can say keep them. You can keep only the top or keep only the bottom. I'm sorry, remove the top or remove the bottom. So the way you get data in Colab, if it's on you got to store it somewhere on your PC. You can run these. Well, first you need to import pandas as PD. Then from Google Colab import .colab import files. And what this down here is going to do is, well, watch, lets you actually browse to find the file you want. And we have Acme cleaning one CSV open. And it loads it right up. And I put because I've got to print the file name, read the CSV in, replace it with the actual file name if needed, and call it DF and give me the head. So here's the head. I'm going to trim it down a little. So I'm going to say df rank equals df, our data frame, the shape of 20 by 8. And just take the last name, department, and salary columns so I can run that. And let's see what that looks like. So that's all we really need for what we're doing. That's how you remove some columns or just keep the ones you want. Now we'll go to the ranking. So with rank in Python pandas, average is the default and returns the mean of all ties with the skip method. There is no SQL equivalent, and the equivalent in R is rank. So if I run this, so it went from 1 to 2 and then skipped 4 and took the mean of 3 and 4, went to 5, took the mean of 6 and 7, took the mean of 8, 9, 10, so on and so forth. First, equivalent to row number and SQL in R, just numbers them sequentially. 1, 2, 3, 4, 5, 6, 7. Well, it's got a little sorting error, but it's still ranking them correctly. Uh, Min uses the skip method for ties and takes the first instance. So that is skip method. 1, 2, 3, 3, 5, 6, 6, 8, 8. So it's skip 4, 7, and 9 and 10. Mac is a skip method. It takes the last instance, and there is no R SQL equivalent. So 1, 2 skips 3, doubles up 4. 5 skips 6, doubles up 7. It doesn't take the first instance as the tie, which would have been 3 in this case. It skips 3 and goes to 4. Skips 6 and goes to 2 sevens. Skips 8 and 9 and makes 3 tens, etc. Dense, no skips. Same as dense rank and dense rank in SQL and R respectively. So 1, 2, 3, 3, 4, 5, 5, 6, 6, 6. First tie, no skips. And the intile, this one's a little different because in SQL and Pandas, uh, SQL and R, I should say, I should change that. It's intile and not. It's only QCut in Pandas. Let me show you that one. QCut, PD QCut, PF rank salary, Q equals 4. That's the number of bins, like intile 4 in SQL. Uh, Labels, we didn't want any duplicates. It dropped duplicates because you can't have any. SQL and Pandas can. So there we go. It's divided into equal quartiles. If we change that to 7 again, let's see what happens there. So it breaks them up, drops them into quartiles. It thinks it looks like it keeps ties in the same group. So the numbers are a little off in the groupings. We should change that. We should say tries to split evenly, but keeps ties in groups. All right, and then one more thing, since I showed you in SQL, rank by department, we'll use just a rank method equals dense, ascending false, and I've got a 1 1 1 1 an admin because they're tied. I got a 1 1 1 IT. So 1 1 2 here where it's just IT. I didn't clean this data and make IT the same. So it's broken them up by department and not a number for Hernandez who doesn't have a department. Okay, so that's the pandas. Let's go to R real quick. I know this video is getting a little long. So in R, I want you to load the tidyverse. This is R Studio. If you're not familiar, you can just download it for free and use R. Tidyverse is a package I use for almost everything. You can see some of my other videos on that. GT Extras is a cool looking table package. We'll just load both of those and clear this off of here. Once you guys get ahead of peeking, we'll start fresh. So I'm going to load library tidyverse, library GT Extras. I'll make a file path to my file. Then I'll use a read CSV and load Acme Cleaning, and we're ready to go. So row number ranks sequentially or ignoring ties equivalent to SQL row number and Python rank method equals first. So Acme Cleaning, last name, department, salary. I'm just selecting 3 rows. Mutate adds a column called row number. It equals row number, salary, descending. The minus is descending. It's just shorthand. Arrange by row number. That's sort in the tidyverse. And pipe operator just pipes one line to the next. It's probably the greatest thing in the tidyverse. So we piped all that in, used Acme Cleaning as our data. The GT and the GT theme just create the nice looking tables. So let's run that. And here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, just like row number. It's equal. Rank, splits, and skip. It's no SQL equivalent, but it's equal to the average one we saw in Python. It does change your data type from int to numeric, so be aware of that. Then we have 1, 2, 3.5, 3.55, 6.5, 6.5. So it's what we saw in Python. It splits and averages. Min rank, sequentially using the skip method, equivalent to SQL rank and R rank. Let's run that one. So rank equals min rank minus salary for the descending. Now 1, 2, 3, 3, 5, 6, 6, 8. So it's skipping. Dense rank. We saw it's equivalent to SQL dense rank and Python rank method equals dense. So this would be the 1, 2, 2, 3. The same as the SQL dense rank and Python rank method equals dense. So we get 1, 2, 3, 3, 4, 5, 5, 6, 6, 6. It's not skipping, it's dense. Intile is equivalent to the SQL intile and Pandas Q-cut we saw. So let's say select, mutate, and arrange. I'm pretty much leaving them all the same. I'm just arranging by the new column. And when you do mutate, you're naming a new column and then telling you what you want in it. Or you can change the contents of an existing column. I'm going to reverse. So on this one, quartile, if I didn't reverse the order here, it would start at 4. I wanted my highest to be in the first quartile. Technically, lowest should be the first quartile. So it broke it up into groups of 5 evenly, just like we saw at SQL. I could change that to maybe do 7. And it's going to leave a couple at the bottom, just like SQL. It ignores ties. Remember, we had to change our Python to say the ties remain in the same tile group or bin. And last, I'm going to show you how to group by department. And then we use partition by in SQL and group by in Python. So Acme Cleaning, group by department, select last name, department, and salary, pipe, mutate. Our rank now equals rank, salary descending, pipe, arrange by rank. In our table creation functions. So this one looks a little weird because I again forgot to clean the data, but let's see here. Sales, Martin, we just use rank. It's going to use the average method. So Davis and Moore, we're tied at 2 and 3, so it took the average. Same here, so on and so forth. That's how you group them. That's it for the window ranking functions in SQL, Python, and R. The next one will be, I believe, the values functions. I get to work on that. But I hope you enjoyed this one. If you did, please like and subscribe. And I'll see you next time. Thanks, everybody.